Hello everyone, today in this video we are going to learn how can we make 433 MHz RF based communication system. So let's get started. Now let's learn about the 433 MHz receiver and transmitter module. So first of all, let's learn about the pin configuration. So VCC and ground are used to power the modules. Then the transmitter is to be supplied with power supply of 9 to 12 volts. Receiver is to be supplied with a power of only 5 volts. Then data pin on the transmitter is used to transmit the data, that is the digital signal. The data pin on the receiver is used to receive the serial data from the transmitter. Antenna pin is used to connect to a single wire, both on the transmitter and also on the receiver. So this module uses the ASK technique for data transmission. ASK stands for amplitude shift keying. So amplitude is varied upon the input, that is 1 or 0. So the carrier signal is usually an analog signal and data transmitted is the digital signal. So ASK offers high bandwidth efficiency. It has simple transmitter and receiver design. It is low cost solution, so these modules are convenient for the hobbies. Then the disadvantages of the ASK is its low power efficiency, and the ASK is more susceptible to noise interference. This module works on the frequency of 433 MHz. You can see the crystal here, which has the frequency 433 MHz. So the range of this module is about 550 to 100 meters in the open area. So this was about the transmitter module and the receiver module. Next, let's look at the HT12E and HT12D IC. So for this project, we are going to use this IC as the encoder IC and the other IC as the decoder IC. So first of all, on the encoder side, the 4 inputs are being encoded, processed and outputted through 17th pin. So the input pins are 13, 12, 10, 10 and 11. Next, 1 to 8 pins are the address pins. So the purpose of the address pins is the security. So in order to get paired these both ICs, the address pins on this HT12E should match the address pins on the HT12D. That means if the pins from 1 to 8 are connected to 0 active low, then the pins from 1 to 8 on the decoder IC should be also active low. Then the 9th pin is the ground pin and the 18th pin is the VCC pin. The 17th pin is the output, 16th and 15th pin is the oscillator pin. So between 16th and 15th pin we have to connect a simple resistor. Then the 14th pin is the transmission enable pin. It should be connected to active low. And then we know that 13th, 12, 11 and 10 are the input pins. On the decoder side, 1 to 8 pins are the address pins, 9th pin is the ground pin, 18th pin is the VCC pin, 17th pin is the valid transmission pin. That means if the encoder IC is sending something to decoder IC, through the transmitter and receiver, of course. Then the valid transmission, this will give some signal. So here we generally attach a LED. Then 16th and 15th pin is the oscillator pin. So here we have to also use a resistor between these two pins. Then 14th pin is the input pin, and the 13th, 12th, 11th and 10th pin is the digital out pin. You can see here we are going to receive the 4 bits of data. So this was about the encoder and decoder IC. Now let's look at the circuit diagram of our project. So on this transmitter side I have used the HD128 IC. So in this IC, for the sake of simplicity, I have connected this address pin to the active low. Then I have connected the VCC to VCC of RF transmitter to the power supply. Then the D out pin is connected to data pin of the RF transmitter. Then resistor 750k ohm is connected to this 16th and 15th pin, that is oscillator pins of the IC. Then the transmission enable pin is connected to the active low. Then through the push buttons, this 11th, 10th, 9th and 8th pin of the IC is connected to ground. On the receiver section, the address pins are also connected to the active low in order to match the security pins. Next, I have connected the power supply to the 5 volt, and which is also connected to the VCC of the receiver. Next, we have connected a LED through this 17th pin, that is valid transmission pin of the decoder IC. Next, we have used a 33 kilo ohm resistor which is connected to pin 16th and 15th of the oscillator pins of the decoder IC. Next, the D in pin is connected to the data pin of the RF receiver. So we have connected the 4 LEDs in order to show what is being received. Now let's look at the testing of our project. So here you can see this is the transmitter and receiver module. So I have powered it up with the 9 volt battery. These switches both are connected to the security pins of the decoder and encoder IC. Then these are the data pins. This is the input and this is the output here. So these data pins are also connected to these 4 of the LEDs. So as you can see, we can send 16 bits of data from transmitter to receiver. So this switches in here, if the position of the switches match, that means the security pins are also matched and our transmitter and receiver is connected successfully. So if I just mismatch the security pins, you can see the LED goes off. That means we cannot send the data and the transmitter and receiver are not connected. So we need to match the security pins first. So you can see the security pins are matched. Now let's look at how can we send the 16 bits of data from the transmitter to receiver. You can see these are the input data pins and these are the output data pins. Output data pins are also connected to the 4 LEDs. So by default, the transmitter is sending 1111 to this receiver. So depending upon the input we select for these 4 data pins, that is 1 or 0, we can send the number of bits from the transmitter to receiver. So you can see when I connect the minus pin, that is 0, to the each of data pins, the LED goes off. So this was the method by which we can send the data. So now let's send the 1 from the transmitter to receiver. That means 0, 0, 0 and 1, which is the binary equivalent of 1. So in order to do that, we have to make the last 3 binary digits 0. So you can see we have successfully sent the first bit, that is 1, to this receiver from the transmitter. So similarly we can send 16 bits of data from transmitter to receiver. So this was our project. I hope you have liked it. Thanks for watching.